Jamal joins?
Yes.
Okay, that would be awesome. Great. And so if y'all can see my screen, this is the last set of notes I sent out where we merged a couple PRs and what else did we do? We talked about behavioral model and the changes for -ACL.P4. So I hope you guys all received this. And what I noticed happened this last week is in the project board, it looks like we got done the flow design here. Can you guys see this okay? Should I size it up a bit? Size it up a little bit. It looks like we had a merge for flow design. This BMV2 side failed. That was fixed by another issue. We had add PLNSG from Marian and what else happened? And then the rest of these that are done this week. And I was wondering, Riff, did you want to talk about 462 at all? Like anything that changed up to the time we closed it?
So we didn't change like much since it's just like addressing a few comments. Yeah, I think all of the comments we got Marian sign off. We got the folks from Alibaba also sign off. So yeah.
Great. So did anyone have questions on the flow design doc? This one's been open a while, but so if you guys want to run through it and have a read, it's already merged, so it's in merge status right now. So
yeah, and it also has a PDF inside, which is actually the site. So if anyone missed the missed the presentation, like the PDF will be there, slides will be there, and also recording will be there. So
okay, great.
Yep.
Great.
If anyone is also having any questions, let me know.
Thank you.
Thank you.
And and then it looks like 515 got done. Marian, did you want to talk us through that at all, or tell us any changes?
Which one's that?
Of PLNSG.
Oh no, it was closed because I have opened another pull request that is pretty much like this one, but I made it more generalized, and it was called tunnel something.
Okay.
Well, it was already merged, I believe.
Oh, okay. Got it. All right, and it looks like we have a couple that got opened, add a missing mask to private link action. So that one's, I guess that one's ready for a review. Were we missing some masks? Let's see here.
Yeah. So
yeah, right. So in the design, there is a formula by which the resulting overlay SIP has to be calculated. So I have updated the behavioral model to match the design.
Yeah, here. Okay.
Yeah, it basically align the current design with latest like design doc. So there are actually two mana fields being like missed over there. So we're adding. Yep.
Nice. Okay. And it looks like, sorry, my computer's a little bit slow, guys. And some more pull requests. Okay, I need to update my connection, I think, at this house. Okay. Rename routing group and attributes, and Mircha opened. Mircha, did you want to talk about this one? The Baby Hero test scale?
Yeah, so I updated the Baby Hero test scale and also started working on some fixes for what the issue raised by Marianne with the routing groups. I saw there is another change for routing groups. So this is about 1% of the scale of the hero test.
Hmm.
And I found few issues here. One, BMV2 by default supports only 1000 or 1024. So this PR also changes the count in BMV2 for routing and mapping. I believe mapping to 8 million, routing to 4 million. The tables, I haven't seen any adverse effects in my testing, but yeah. And there are some to-dos which they don't need to happen for this PR to be accepted. One, basically the ACLs are not present in this config because we have those issues with the ACLs. Then I need to add routed IPs, so the ones that are not mapped to the test. Maybe increase a bit the performance of BMV2, so at least when we have so many packets, the runtime, it's a decent amount, basically. If we send 5 packets per second, then there are 160K, and it's gonna run for forever. But not increase it by much, but even if it's like 500 per second or something, it's gonna be a decent runtime. And then inside Challenger, if I update the TPU gen, it doesn't build the container anymore. And it seems it's from side Challenger, and then it's from Psi. So it has something to do with actually with Debian. The versions that it uses, it's older, and one of the repo user, it's not working, and then it errors out, and then the whole container build fails. I have a workaround for it, but I contacted PL Vision to see if they have a better fix than mine. But for now, I submitted the config file as is. Now it's a large file. It's almost like 90 meg, the JSON. That shouldn't be there. But as soon as we figure out this container build and everything, no, the yeah, this JSON. Yeah, it's not displayed basically.
Okay.
So
and if I add the ACLs, actually goes over 100 meg, and then I cannot submit it anymore because of the Git limit.
So
yeah.
Mitch, I have a few big comments to this PR, and I think we need to address them. Yeah. So the first of all is that all the tests are generated, right? It's randomly generated. So there is one big file, and every time, because it's random, so every time we regenerate it, it will change. There is no way to maintain that file. So if there is any issues,
it's not random. The file, it's always the same.
Yeah, there is no way to maintain that file. No one will actually review than 200K lines of code. Okay. So
okay,
let's be honest.
File, correct.
Yeah, there's no one will actually review it. So anyone that changes it, right, it will generate like millions of tests or 100K of tests. And if we see like say 10K of tests is changing, there is literally no one will actually know what is actually happening. Okay, people just blindly approve, right? So that means that if it is random, if it generated one, at least we should put it in somewhere like outside of the repo. It can be generated from into the temporary file, if in memory, because what I'm seeing is that there are some issues in the side Challenger. You cannot read it from the memory directly. You have to put it in the file. Sure. Then we can generate it into the file, but not in the code base. Okay.
Yeah,
so,
I wanted to mention something too. I thought about this. Merchant, if you check this in, even if you delete it later, it's going to be in the Git repo database, and it's going to really burden anyone doing a clone. Yeah. Right? It stays in the Git history. So
then let's flip it to draft till that problem is solved. And we make that to do as mandatory for accepting this PR.
Yeah, I think this is the very the first thing is that we need to put it outside of the repo. So somewhere you can choose. It's totally like up to you, but we cannot get them file quickly. The second thing is that I'm actually very hesitant to put it as part of the CI. The reason is like this. So if we put something in the CI, there must be a purpose, right? Because we spend the time, we reduce engineering, the engineering efficiency, right? So we should gain something. So putting the hero test is usually for performance. All right, so speed, memory, no matter what you call it, it's all about performance. It's about scale. The things for the scale is that it's really hard to actually assert something is going wrong, which is actually the purpose of the CI. If the CI fails, that means that we need to. It is something explicit and failing. It should be actionable. We will know, like, yes, it is actually a fail that we can easily tell. The things for the hero test is that it's really hard to make that assertion. So for example, if we take let's say 10 minutes for now, right? Run all the hero test, just like you mentioned in the comments. And so let's say in 1 week, it takes 10 minutes and 30 seconds more. 10 minutes and 30 seconds. So we got 30 seconds more. Is that a failure or is that not a failure? So right now we are using 200 megabytes memory. In the future, we use 210 megabytes memory. Is that a failure or is that not? So it doesn't really serve the purpose of the CI. It cannot guard anything. You cannot tell if it is a regression or it's not a regression. But I'm with you. It's great to have a baby hero test. So I'm just saying that it's probably not a good idea to put it in the CI.
So I think I'm wondering. Yeah, I'm wondering if we can, I can talk to you guys and we can maybe pick this up next week because we have Jamal here who was going to present on P4TC, but I have some comments on this too, Riff, so we can talk about it if you guys don't mind.
Yeah,
like
totally.
Okay, cool.
Like,
yeah, so I'll run.
Also discuss it offline.
Yeah,
and
absolutely.
I'm very excited to see the P4TC.
Yeah. Okay. Thank you. And thanks, Mircha. Yeah, let's flip it to draft and keep going.
I flipped it already.
Oh, thank you. So everyone, I wanted to introduce Jamal. Jamal, if you're still here. And Jamal was going to show us a presentation on P4TC, P4 traffic control. Is that right, Jamal? And I think you're on mute, possibly. Jamal, I can introduce you to everyone here on the call. I'm Christina, and I lead this repo. But
sorry, I'm on mute. Okay.
Yeah, it's okay. But we have multiple different industries, companies, switching, ASIC, et cetera here. So very excited to hear you speak about P4. You're welcome to. I can stop the share, and if you're not familiar with Teams, how you do it in Teams is just that up arrow share button. If you wanted to share something.
All right. Sorry, I can turn off the camera, I guess. Just I'm on
Yeah,
Wi-Fi.
sure. Yeah.
There you go. So we can go in different directions. I'll start with something, and then maybe I could go all the way to a certain point, and then you guys can interject and ask questions, etc. I don't know.
Maybe you could introduce yourself, Jamal.
Oh, hi. Okay, I'm Jamal. I work for a small company that's out of Ottawa, Canada. Very specialized in networking, data path, Linux. I've been doing SDN before SDN was hype. At some point, I was the chair of the Forces Working Group at the IETF. Those were dark days for open networking because the whole standards body was controlled by a few big vendors. If they don't deploy, your protocol or your proposal goes nowhere. So we were in the early days. I was also very involved in the NPU world. I don't know if anybody remembers that, where multiple vendors were just building ASICs for packet processing. It was the precursor to, I don't know what the comparison is, but that market didn't take off. And ever since so we've worked with several big companies that deployed our software privately. We're not very public. I don't know. Do you want to know more?
No, that's great. Thank you so much. And you're gonna show us what you have about P4 traffic controller.
Yes. So this is
Great, thank you.
yeah. I can, like I said, we can wing it in different directions. This is just very high level.
Jamal,
Yeah, sorry.
before you get going, I just want to tell people there you can go to p4tc.dev.
Sorry, yes.
I'll type it in the chat window. And I have actually downloaded that and played with the tutorials. And also, Jamal, I think there's going to be some real geeky excitement about some of this. And where can people continue learning and interacting if they want to learn more? Because if we run out of time, there'll probably still be, appetite.
So p4tc.dev is correct, is a good starting point. Sending me email. We're very open to receiving email. Very helpful. You'll find us to be extremely helpful in terms of responding. I have some links at the end, but we could, like I said, we could wing it in any direction you guys want.
Thanks.
I do recognize a few names here. I know Marian, I know Andy. Sorry, and of course Chris. Nobody else.
Awesome.
Yeah. So by the way, Marian was very involved in the early days to try and get P4 into the Linux kernel. That didn't go very far. Well, this is probably the most prolific attempt is what we're trying to do. So the what and why, I mean, we are presenting a software and hardware data path with a single API. So when you write your control plane, the access, you can specify on your API calls to add table entries, for example, whether that entry goes to hardware or to software. So there's a uniform API. And when you compile the code, you can select to have either both software and hardware. And when you select, you tell P4C, the compiler, to generate the software data path, it gets generated in eBPF. When hardware support is needed, then it will depend on the vendor. So it will generate a binary blob, and I'll show a little bit of this further on in the slides, which gets loaded to the firmware as firmware to the driver by the driver into something that the vendor understands. As to why the Linux kernel, well, the most important detail is it's very widely deployed. So we're going to try and take advantage of that, as opposed to putting something out and hoping you and a few of your friends or some companies that want to use it have access to it. So it helps at least make P4 very widely available and ease the ability to run it. We also are looking for vendor interface independence, so you can have multiple NIC vendors for the hardware offload, but it's the same API. So the burden lies on the vendor to go and update their drivers to meet these requirements. And probably the most important advantage is we avoid bit rot. So projects gets abandoned. You'll see a lot of P4 projects that are dead or were written by somebody who got their graduated and it's over. It's just sitting there, hasn't been updated in 8 years, or people run out of time. Once we put it in the kernel, what you have is the API, at least whoever fixes the API fixes your code as well, because it has to compile across the kernel. So that's some of the reasoning. That's why we're doing Linux kernel. So please feel free to interject. Now, as to where we are, the kernel code is complete, is ready, we should say, minus any challenges we meet. Mostly, occasionally, we have a bug fix because we are running continuous CI on this code, or sometimes as a feature enhancement. I think, for example, one feedback that came from Chris, I think yesterday, was we were not allowing a register index of 0, I'm sorry, and that's going to be a feature enhancement in probably by next week. It should be ready. Extend support. is there, but there's still gaps because the compiler piece is not totally done. We are doing extends in a slightly different way than probably other P4 implementations, in the sense that we allow the same control plane API to be also used for extends, and we generate as much code as we can to enable you to, for example, the software data path to use extends as well. And this could be custom extends. The upstream process is very challenging. There's I don't know if any of you have been involved in upstream. There's a lot of, none of it is technical. The technical part is fine. It's about 80 to 90% of it is, but why didn't you do it this way? So it's very, very time consuming. I would say I would budget 60% of my time spent on the politics, I guess, of upstream, more than writing the code. And there's a bunch of us working with this, but the big group is upstream processing in Linux has become very challenging. And if there's not a lot of P4 users in the kernel community, and majority of question is, well, why don't you implement something else that's not exactly P4 so I can use it for my proprietary hardware or something like that? And a lot of this is noise, which gets lost in the mailing list discussions. We'd like help. Chris has been very supportive. He does show up and comment. The initial comment, I think we've gone past the part where they say nobody needs P4. That was the initial response. When we first posted the patches, the general comment was, why does anybody need P4? This is nonsense. It's some industry thing. So I think we've jumped that hurdle. There's still some of that, but it's in the minority. The majority of it, and some of it is just, some people say things and then they don't take them back because of their position of authority, etc. But it's not a trivial process. But we believe it's worth the effort, because this will be very useful once it will be impacting once it goes into the kernel. I'm sorry I spent too much time on that bullet, but it's something that's we've been dealing with on a daily basis, probably for the last 6 to 8 months. The compiler is still work in progress. I have some features needed for Dash that I'll list afterwards. The most things that are being wrapped up right now are the custom extents, which I'll try and describe after. The features for Dash, we look at Dash as one of our use cases to test how well this works. Drivers is work in progress. Intel is working on one. It's going slowly, but it's available. It will work on the MEV to a limited number of constructs on P4. The other vendors that we have bi-weekly meetings where the vendors show up. AMD is there, NVIDIA. It's mostly very geeky discussions on, well, what should I call this callback in the driver to do? And sometimes we bump into issues where we need to either address P4 constraints or kernel constraints that don't quite fit into the driver. Are there any questions?
Jamal, I just wanted to add something on the politics. I weighed in on some of the kernel discussion threads to try to explain why P4 is important and valuable. And there may be people in this meeting, in this working group, who feel like they'd like to lend their voice and support. And there's a way to jump in on some of these threads and make a comment. It is helpful. We've already turned the tide on some attitudes. So if someone feels like they can withstand some of the Linux flame wars that occur in these threads and voice their support and be prepared to get a little bit of pushback, it would help the cause. So if you're interested, maybe let Jamal know and he can help guide you where your voice might be useful. Is that fair to say, Jamal?
Yes, absolutely. Thanks for all your support, Chris. I mean, I think we've turned the tide on nobody needs this. And then it became nobody needs it for software only. Why don't, but then we won't allow you to do hardware offload only. So,
right. I think we're chipping away.
It's a long process.
Yeah.
We'll have a breakthrough, but yeah, the more people support us, even by saying, look, we are looking at P4 for software only for our project like Dash, that carries some weight because the it's a lot of very, I hate to say this, very left brain thinking in the, if it doesn't suit my use case, it doesn't make any sense. And the more people who chime in and say, yeah, we need this, for example, just the software, we need software only. So like I was saying, the biggest advantage is it's the same API, whether you're doing software only, you can definitely not, you don't have to load in the software version. You can entirely do everything in hardware. Like, you use Linux as an API to the hardware, basically. Okay, comparison from other data paths. This one was built from day one to support both hardware and software API integration, meaning that you could actually run the P4 program on your laptop, and then when you're ready and you have the right NIC with the driver support, it's exactly the same application you have in user space that will run. The only difference is when you're adding the entries or when sending your policies down to the data path, you specify whether you want it to be loaded in both hardware or software, or to be best effort hardware and then it falls back to software, or to be software only. So your logic will decide in most cases how this data path processing happens. We're definitely going to be slower than DPDK, because DPDK dedicates whole CPUs to the processing, whereas the kernel is a general purpose operating system. There's some overhead in the kernel in terms of the buffer management, etc. Will absolutely be, I think, a magnitude faster probably than BMV2. Any question on which other data path you may be interested in? I believe Dash uses BMV2 right now.
Yep.
Right. Okay, Dash status. Yeah, we have attempted to compile Dash, and we ran into a couple of issues. One was computations involving 128 bits or bigger. That is being worked on as we speak. Support for variable bit, multi-parameter in the parser and the deparser. That was not supported in the eBPF generation, so we're adding that. And we believe those are the only two outstanding issues we know of. There's a bunch of them that have been fixed over time. And there may be issues once so the first stage is let's compile Dash, make sure it works, and then let's run it. So we may bump into issues when we start running it, we're not sure. We'll find out. Right, control plane, if I understand correctly, Dash uses P4 runtime. We don't have P4 runtime support. We just have APIs, which I'll show, C APIs. That's the only language you support right now, but it could be easily wrapped around Rust if that's of interest.
Jamal, can I interject right here? Because I may not have explained thoroughly when I gave you a real brief feedback yesterday.
Mhm.
Dash only uses P4 runtime because it had to, because that's what BMV2 supported.
I see.
So actually the real API we're using is Psi, and there's a Psi to P4 runtime translator that Marian actually came up with. And the same principle could, in theory, be used to create a Psi to Netlink, native P4TC API. And P4 runtime isn't really something that we need. It's something we just utilize.
Oh, that would be great.
Yeah, it'd probably be more performant because
Yes.
you don't have to go over gRPC.
Yeah, I'm not a big fan of P4 runtime, but that's a different topic.
The other place we use P4 runtime is actually generating the Psi APIs. It just serves as a spec. So that's another place.
Yeah, when I go over the APIs, you can tell me if that would suffice or you would need something more. I have a slide or two on the APIs.
It's just table CRUD translation is all we're doing.
Oh yeah, so we're definitely very CRUD friendly. You'll see when I show the APIs. So yeah, and of course we expect that the DPU, as long as the driver supports it, it should work. DPU, SmartNIC, IPU. Okay, so the workflow, how do you build this? You basically start with your P4 program. This is kind of a recommendation more than anything else. You can then tell the P4C compiler you want to compile for P4TC. That generates a bunch of things in green. right? So the first one is what we call a template. Sorry, this is an eBPF program. If you're interested in data path that's in software, this is what you get. If not, this piece here is generated for everybody, including software. So if you're not using software and only interested in hardware, you still a script gets generated for you that when you run these scripts, it manifests whatever your program's pipeline looks like, the tables, the actions, and the extras. Those are now getting placed in the kernel. This is using Netlink. We have an application. We extended an application called TC that's part of IPROC2 packaging in Linux, that you execute that and it manifests all your objects in the kernel. And if you're using software, then your eBPF program has to be compiled. And once it's loaded in the kernel, you can start using it to, but the objects reside in the kernel, in the TC side. I think I have another slide. If you have a hardware vendor, then if you have a hardware offload, then of course you use the backend that belongs to the hardware vendor, or could be a proprietary compiler here. And then you load the binary blob into the hardware. And what we've been playing around lately as part of those discussions is, if I'm going to target a table, I would need to make sure that it belongs to the correct program, has the correct IDs, so that when I send it to the hardware, that the driver agrees that you're targeting the correct program and the correct hardware table, for example. So there's a whole write-up on that, which we can go over it if there's interest, but just as a concept that, the software data path is sharing the control objects with the hardware data path in terms of names, pipeline IDs, pipeline names, table IDs, action IDs, parameter types. These are all manifested through this, what we call the templating language. There's also a JSON file that gets produced, which we call the introspection file. That is more for humans than anything else. That you would, if someone was to describe a table name, then you think of it as a name to ID resolution, and a type resolution as well, parameter type resolution. So when you're running at runtime, your P4TC control application in our API, we basically, when you write this app, you essentially just suck in that JSON file, and then you can use a concept that looks very similar to Unix paths to address the different objects. So this is where the P4 runtime objects reside, which is what I was describing, are created by these bash scripts. So if you're only doing software, you don't need to go this path. You just basically, the objects are controlled via this arrow here. If you are doing hardware, then you go this path. And if you're doing best effort hardware or software, then you just don't specify whether you want it to go to software or hardware. In presence of hardware, the first attempt will be to try and use the hardware tables, and on failure, then you get to use the software ones. So the software becomes a backup in case there is no space in the hardware, right? But if you're smart enough, and you specify in your P4 program, I don't mean smart, but if you want to have more control, then you can specify how many entries exist on a specific hardware table, and then these will get the intersection between control and data path will object to your program to say, look, I don't have any space anymore in hardware. So there's multiple variations of how you would control both software and hardware. You could use the software as only exception paths. You could split your pipeline into hardware only for some parts of the table flows, and the rest shows up as an exception into software. You could have all your table misses go to software. There's variations of how you could do this. Any questions on this? So one of the things we did is the eBPF code as well interacts with tables that sit over here. We implemented for tables an equivalent to an algorithmic TCAM, so you can do exact matches, LPM, ternary, You can even do ranges with the correct clever trickery. And of course, recirculation resubmitting goes through this. The one thing to observe here is you can as well generate, you can say my P4 program in software only sits in XDP, or it sits only in NTC layer. Or I could split it in a way that, you know, the first path maybe is done in the XDP code and the rest is done in TC. I'm not sure if people here are familiar with what TC and XDP are, but they're just essentially hooks to inject eBPF code. Any questions on this?
So although it's called P4TC, but it does also generate XDP code and then
Yes.
serves.
Yes. So yeah, exactly. So it's eBPF code. Yeah, the name is called P4TC because initially that's where we started. In our early days, we did not use eBPF. We had our own scriptable language. The goal was to never touch the kernel anytime we change anytime we change code. So you have a P4 program, you shouldn't have to change anything in the kernel, period. So initially we didn't even want to use eBPF, but part of the pushback is saying, no, you have to use eBPF. So that's why we spent another 9 months rewriting our code to do eBPF. Right. So part of the pushback in the mailing list was, so our code was ready about a year ago. They say, no, more than a year ago, you have to use eBPF. So we got rid of a bunch of code here. And so we had already called it P4TC at that time because there was a scripting language that resided in this area here. One thing to observe is these blue arrows here. These are API calls from eBPF. So any external will have to go here. Anything that requires some sort of better Turing completeness will sit here. eBPF has some challenges with doing fast. If, for example, if you had a very big ternary table, the compiler is unlikely to generate enough. The loader for eBPF will probably reject your code because of the loops you have to run.
Jamal, quick question on that eBPF. What does generated mean there in that brackets? Because that's code that is developed, right? Not generated. Or what am I missing there? Is it a plugin?
You get the pseudo C code that is eBPF, and you compile it. Right.
Okay.
You compile it with Clang, and you get a binary. Then you load the binary. So this is C code. You shouldn't be looking at it, but you can inspect it. Occasionally, we still do inspect it. It's even the indentation sometimes is not very good, but it's not intended for humans. The idea was we make this work. And we could probably make it a lot more efficient, but our philosophy is make it work first and then optimize after. Yeah, that answer the question?
Yeah. That's where you want to potentially optimize for speed up and performance and other benefits there with that plugin.
Only, right? For software only. If you want to do hardware, right, you don't really need this.
The real optimization is to offload into hardware, of course.
Yeah.
Right, of course. Yeah, that's the end goal.
Yeah. So yeah, you really want to be using this. You may want to use this for exception handling, or there are cases where table spaces or resources here are not sufficient, and you may want to pick some things that end up going in software only. And there's some challenges which I'll speak about because sometimes there are cases where it may not make sense at all to even have a program here. Right. Okay, so the control plane integration, what I was talking about is the APIs. They look like this. I don't know if you guys are familiar with Netlink, but Netlink has a wire format that goes on between the kernel and user space. You have a Netlink header, and we inserted our own header here, which provides a noun. Actually, let me talk about this. This is the CRUD general overview. You have a verb, which could be a create, delete, update, any of the CRUDs. In addition, we have a subscription. You can subscribe to certain events. So that's why we see it's called CRUD plus implicit S plus P, subscribe and publish. So the kernel could publish things that you've subscribed to. So you have a verb followed by a noun. So the API, if you look at it, it's very simple. It's a verb, noun, optional data. So if you're just doing a get or a read, you really don't have any data. You're just specifying a path to a specific object, maybe with a specific key, and you could further qualify it. This doesn't make sense to say exact match with a priority, but you could further qualify it by giving the key to the entry of interest. And if you leave out the key, you're dumping the whole table. You're grabbing the whole table called my table, which happens to sit on my program, control one, block control one. You can also create a single entry by specifying the create as your command and followed by the path to the table. So there's a path, Unix-like influence here, and an entry. And you specify, again, priorities don't make sense for exact matches, and an action to run. You say, okay, action, which is defined in my prog, control block control one, drop. Or we've built in from day one batching capabilities. So you can say create, and then you specify a bunch of entries you want to create. Right? So our goal is to have compared to other netlink-based approaches, is to try to introduce very high throughput and low latency. Of course, if I go back here, the driver also has a role to play. If this is slow, then it will slow us down as well, right? So any questions of this? So that's why we call it the CRUD X. X implies execute as well. It's one of those things not totally complete, but you could actually send a control message to the kernel to execute something on your behalf. So this is how the API looks. Sorry, go ahead. Go ahead.
Yeah, I have one small question because I remember you mentioned that P4TC actually needs some kernel support because the upstream has some problem, and but from so far, I'm not seeing anything that needs to change the kernel. So either maybe I missed something. Do you mind to like?
Yeah. So there's initial code we have to push. Right, that code is entirely essentially sitting in this area. The code that allows us, let's say, when we're manifesting the objects, that's the majority of the code. That we can create these objects from the kernel, from user space. You say, okay, here's my program. It has the 4 tables. This table is an exact match, which takes the following type keys. So you have to create the objects, and that's the code we're trying to push.
I see. I remember like eBPF has the capability to run certain code, and also it defines the tables. So is there any extra things that we need
Sorry,
to support?
Say that again. I missed that. You said eBPF?
Yeah.
Okay, what about eBPF? This code or a different eBPF P4?
I mean, the eBPF itself actually supports like tables and also some,
Yes.
Yeah.
Yeah, but I mean, you can make them. Okay, so number one is remember that we're sharing this between the hardware and the data path. These objects there is no path from eBPF to hardware. That doesn't exist. So this is why we can't just use an eBPF program here and then put the table, because the tables will have to reside on this part here. Not just the table, yeah, the extras, all kinds of objects, some of which have not got a good direct mapping to eBPF objects. You can make them work, but it's a lot of acrobatics. Tables alone, eBPF has something called maps.
Yeah.
You could probably get most of your tables working, but our goal is to put them here. And eBPF doesn't allow you to move their code into this space, right? Because they claim they have a lot of security, et cetera, et cetera. If I'm just doing hardware only, I don't need this part at all. I don't need eBPF. I'm just gonna not even load that, right? I'm just doing this. I still want to use the same control plane API.
So you want a single control plane API that's new with this work, I think. you can correct me if that's wrong, to either program eBPF tables if the software offload is being used, or program the hardware tables if the hardware offload is being used, or both.
The first part is we're not programming eBPF tables because then they will not be accessible to the hardware. To program the eBPF tables, you have to run eBPF code. We have our own tables.
You have the option to run eBPF code.
It's very, it will take us about 10 years to try and submit patches to get that to work, because then we'll be taking the tables away, from
I'm saying
this part to
one of your paths is to go to an eBPF binary, right?
If you need software, yes, you load this part. But this
So,
has to talk to our
your
tables.
P4TC control APIs should affect how the tables of that eBPF code.
Yeah, so we are not allowed to, if we wanted to keep this API, which is for both hardware and software, then we would have to be able to update those tables from the control plane. eBPF has its own control plane. That control plane has no access to this path here. If you could go and write two control planes, right? You could go and write two control planes. You could put one here that just talks to eBPF. Then you'll have to have another layer on top, so that
so sorry. So this P4TC control is a new API that you've created, or it's an existing one?
No, it's the way Netlink works is you create objects and then you can start talking Netlink to them. So it's not so much a new API other than a new Netlink object, which is very common way of adding control to the kernel. So
the new Netlink objects that you create are not eBPF objects.
They're not eBPF. They're not. Because,
but when you add entries to those new Netlink objects,
right?
Do you have or plan to implement kernel code that automatically then, as a side effect, says, I've got an eBPF program loaded that should be updated as a result of that Netlink object having an entry added to it?
I think we could do that. Right now, the common practice is, hey, do you want software data path? Then you load it, right? And because you have to specify exactly where you want this code to run, which interfaces, etc. So the human has to be able to say, well, okay, I got this 60 interfaces. I only want it to run on this 10, right? So yeah, I think what you're suggesting is I'm going to try and do this, and then someone's going, oh yeah, they need software, and then I'm going to go to the control planes and load the eBPF code for me, right?
We've got about 8 minutes left. Just
sorry. Yeah, that's
you might want it.
So the P4 runtime objects themselves, both the incarnations, the light blue box in the P4TC and then in the driver box, the dark blue, right? They're either or, and is there a possibility that a use case needs both, maybe like a punt path interface or something like that?
Yes. You could have your exception running here, exception path, and they could be mirrored. It could be the same table, but some entries are here and some are here, right? Chris, did you say we're running out of time? Maybe I could just quickly go over this.
Well, we have like about 8 minutes or so, just however you want to split the time.
And we can always bleed it. We could always do a second session, Jamal, too.
Okay. So there is the API. This is how a C API would look like. You basically create, you specify your object in ASCII string. You can provide your data. We provide APIs to construct the data. You can subscribe to something, and when you subscribe, you can specify a filter. You can delete. Okay, this is missing a filter, but you can delete with a filter as well, right? Which is very, very useful if you have a million entries and you just want to delete things that haven't seen a hit in the last 5 minutes, for example. Okay, here's some example with filtering. And this is using the TC command line utility, but imagine this is the same way you would run it using API. You say TCP4. This is just an application, okay? It's not dogma here. Say, I want to run an event so that anytime you see a command called create on this table called tname3, and it has an action, which is a send next hop with this MAC address, please send me a notification to the control plane. Just a simple, or delete all the entries in table name 4 that haven't seen a hit in the last 10 seconds. Right. Extents. We added a lot of annotations to teach the compiler how to generate code so that it's, again, the control plane could still be used. It will generate a proper introspection. If you write your code, I guess the only thing would be to make sure that there's a path to your extent of interest. So these are not exactly P4 constructs like publishing and subscribing, but these are Linux constructs that are very useful. You can write your own custom extents. I don't have a diagram here, but you could write whatever extra code you want as a kernel module. We have a very specific module APIs for the kernel callbacks for writing modules. So you could write some complex code that doesn't quite fit in, describable in P4. And then basically from this picture here, the eBPF code will just invoke an extern, which will be sitting here, and you could have loops and other interesting things, or proprietary code, etc. It becomes a loadable kernel module. So that's how we do externs. Digests as well. Digests appear as events. You subscribe to a specific digest. The most simple one is you say monitor my programs P4 all programs. However, you could say only for one program in case you have multiple programs, or only for this specific digest. Again, the way that works is your application essentially sits here. You send your API call and it for subscribe, and you specify the path to that object, which happens to be a digest, and you can have multiple listeners to this. Right. So challenges. There's some P4 challenges. If we do this again, I could go into details. There's an impedance mismatch. Probably that's what Murali, I think, was maybe alluding to earlier. So in the simple case, the way Linux works is your software data path, input versus output, have the same, have to mirror what's in hardware. So this works very well, right? You can split your tables in here for software. You have this exactly the same pipeline on both sides, and put some of the table entries in software, whereas others sit in hardware, depending on what your desired policy is. Or you can have misses going to software, and then perhaps that generates events later. Okay, we can talk about. I saw your message, Christina. So I can stop here.
Sure.
I can stop here, but we can maybe you can tell me what you want to see next. Then I can prepare slides of that.
Yeah, guys, is there anything in particular you'd want to cover next, other than I think we could do like an overview and then on to the challenges in the future work?
I think he had a slide around performance, so that's something we may want to hit next time to see, what the ongoing experiments look like.
Mm-hmm.
Yeah, I think Jamal, I think you got people's appetite whetted here.
Mm-hmm. Got it. Well, thank you, Jamal. I'll go ahead and make sure you get the notes on this call and presentation, and Pedro as well. So I'll do that. I usually do that by Thursdays, and let me know when it's convenient for you to cover the rest, and that would be awesome. And I'm going to go ahead and stop the recording now. And Jamal, just so you know, these are I upload these to YouTube. So you'll find you'll find this content in the YouTube channel. And so I can make sure you have the link it's usually in the meeting notes at the bottom, Okay, yeah. So, great. I'm going to stop the recording and